Equivalent expressions with common denominators, specifically denominators of 10 and 100. Okay. So again, taking the exact same thing we've learned and just giving us one more little step. Now, instead of just seeing that 2/10 is the same thing as 20 over 100, instead of just saying that, we're throwing in this extra adding as well. This is giving us the baseline for common denominators, which we'll be doing in a little bit. In my video at the start of this stream, I talked about how and why common denominators are useful. Other than changing the denominator from 10 to 100, I don't even know if there's going to be a lot of common denominator finding here in this 4th grade curriculum. It might be something that happens in 5th grade. We will find out. A bunny's ears grew 14 over 100 centimeters last year and 4 over 10 centimeters this year. Which of these expressions is the same as that? Okay? So again, you got to have the common denominator. We can't have hundredths and tenths adding together. They're not the same. They're not the same denomination. So we can't just count them all up. It would be like having some $1 bills and some $5 bills. I wouldn't just want to count them together and say, I've got this number of bills. I want to know how many of them are ones and how many of them are fives. That tells me how much money I've actually got. Same thing here. So instead of 4/10, we're going to call it 40 hundredths. Let's see. We've got 1/16 over 100 plus 5/10. 5/10, as we've seen several times during this very stream, is the same thing as 50 over 100. They're not even asking us to do the addition yet. They are just asking us to take that sort of half step towards making the common denominator, and I assume we're going to be doing the actual addition in a later topic. Malati divides a deck of cards into 2 piles. One pile is 12 over 10 centimeters tall, and the other pile is 89 over 100 centimeters tall. Wow, that's a really, really tall, 89 100ths of a centimeter. Okay, I was about to say, if it was 89 centimeters tall, that would be ridiculous. All right, so 120 over 100, 12 over 10 is 120 over 100. So we end up getting 120 over 100 plus 89 over 100. Which expression is the same as 1/10, which we've already determined is 10 over 100, right? Not 10/10, not 1 over 100. In both of these, in this one, part B, the mistake is that they multiplied the top times 10, right? They had 1/10 for both of these. In this one, they multiplied the top by 10, but they did not multiply the bottom by 10 as they had to. If you don't multiply the top and the bottom by the same thing, then you're no longer equivalent. Okay? You need to multiply by 1. 10 divided by 10 is 1. That's okay. You can't just multiply by 10. That changes it. Same deal with this one. It didn't multiply on top, but it did multiply on the bottom, right? It got the 100 on the bottom, but they forgot to multiply the numerator by 10 as well. The correct answer is D. So she made 2 big snowballs for a snowman. One snowball was 4/10 meters tall. The other was 65 over 100 meters tall. Well, that 4/10 is the same thing as 40 hundredths. Then we just have to make sure that we have not changed our 65 over 100 at all. Like D here is a little bit tempting because it has the 40 over 100, but 650 over 100 is not the deal. Finally, 13 over 10 is the same thing as 130 over 100 plus 5 over 100. Boom, and that's that.